Now the next topic, that is electric field. Okay. Now see, suppose here as shown in this figure, at the origin of Cartesian coordinate system, we consider one charge capital Q. Now suppose at position P, having position vector R, we place any other charge small q, then we know this thing as per Coulomb's law, the force on that charge, that is F equal to K Q upon R square into R caret. But see here, we can say this thing, this charge capital Q exerts some force on this small q. But think like that. Suppose this small charge Q is removed from P. Now nothing is there at the P, right? Charge Q is removed. So anything left behind at P if charge small q is removed from that? So in general, we give answer, no, nothing is there. No. The effect of this capital Q charge is prevailing there. And that effect that we can experience when we place any charge at that particular position, but if this particular charge is not placed at that point, it doesn't mean that there is no effect of this charge capital Q. And the effect of any charge prevailing in the surrounding space of it, that is represented by electric field. Just like the concept is gravitational field. આપણે અર્થના ગ્રેવિટેશનલ ફિલ્ડની અંદર કોઈ ઓબ્જેક્ટ પકડી રાખ્યો પછી છોડી દઈએ તો એ ફોર્સ એક્સપિરિયન્સ કરે ને અર્થ ઉપર પડી જાય. પણ ધારો કે આ ઓબ્જેક્ટ આપણે અર્થના સરાઉન્ડિંગ સ્પેસમાં ના રાખ્યો હોય, તેનો મતલબ એવું કે અર્થનો ગ્રેવિટેશનલ ફોર્સ નથી લાગતો ક્યાંય? એ તો છે જ, એની ઇફેક્ટ તો પ્રિવેલિંગ છે જ. બટ ધ થિંગ ધેટ ઇઝ, આપણે એક્સપિરિયન્સ કરવા માટે ત્યાં ઓબ્જેક્ટ મૂકીએ છીએ. સો એક્ઝેક્ટલી લાઈક ધેટ, the effect of this charge capital Q is prevailing in the surrounding of it. No doubt we can experience it when we place any other charge in the vicinity of it. So here this capital Q charge, that is called source charge, and this small q, that is called test charge. Now the effect of this capital Q charge prevailing in the surrounding space of it, that is independent of this test charge. કારણ કે એ તો exclusive capital Q ની જ property છે. Okay, so suppose here in this particular equation, F equal to K Q upon R square R caret, we take this small q on left hand side, then we can write F by Q, that is Q upon R square R caret, and this particular right hand side of the equation, that is independent of this particular test charge. So this particular quantity obtained here by taking F by Q, that is called electric field of this charge capital Q, that is the source charge at point P. So now this F by Q, that is nothing but the force acting on unit positive charge. So now we can give the definition of electric field like this. The electric field at any point of the given source is the force acting on unit positive charge placed at that particular point. Okay, so this one is the concept of electric field. Now, the unit of electric field, that is for force Newton, for charge Coulomb, so that is Newton per Coulomb. And its dimensional formula, that will be dimensional formula of force upon dimensional formula of charge, and that is m1 L1 T minus 3 A minus 1. Here, when we calculate the electric field of any source at any point at that time, we require a test charge. But here, this test charge, that should be very small. Limit q tends to 0, that we have to take, so that this particular source, that should not be disturbed here. Okay. Now, the direction of the electric field at any point, that will be in the direction of the force acting on unit positive charge placed at that particular point. Okay. It implies that suppose we take the source charge, that is positive charge. So in the surrounding of it anywhere, if we place the unit positive charge, then the force will be repulsive force. It implies that the electric field of positive charge, that will be radially outward. Now, if we take the source charge, that is negative, then in the surrounding of it anywhere, if we place unit positive charge, then it will attract. So we can say the electric field of negative charge, that is towards the charge. That is towards the charge. This one is the concept of electric field. Now, why this electric field is very important? Because once we find out the electric field at any point, then whose electric field is this one? Which type of charge distribution is there in the source? No need to think about all these things. Just at any point, suppose here P, we calculate the electric field. Then after, if you want to calculate the force acting on any damped charge placed here, so see, from this equation we can say force, that is Q into E. So here if you place charge Q1, then Q1 into E, force. If you place charge Q2, simple, Q2 into E, force. If you charge Q3, Q3 into E, the force. So we can say, in other words, electric field at any point, that is the representative of that charged system, or we can say source system. Clear to all of you?